All right. Okay, so today's topic, we actually started last week. Remember, I sent you the notes. We went through the slides.
Yes.
Okay, and then we are going to do a bit more today for this topic. Okay, hold on. I let the student in. You here. All right. Hi, Vidyu. Good morning. Hi, Vidyu. Okay, thank you for turning on the camera. Let me just share with you, all right, a quick summary using a video. Okay, right, so you saw the video and you saw the particle arrangement. Okay. Go on. Let me just turn this on. Now I want you to look at the slides. Okay, and you need to take some screenshot. It's not sharing, right? Can you see it now? Yeah. Okay, so for this topic, it's still on the states of matter, but today we focus a little bit on the melting as well as the boiling. Okay, so if you can, all right, try to recall what you have learned in primary school about solid, liquid, and gas. You know the properties of each of them, right? And their properties are actually determined by their particle arrangement. Okay, so you've already got these notes from last week. Okay, so there's no need for you to copy or screenshot. It's the next one, actually. So always remember, okay, so the forces between particles, these forces between particles are very strong inside the solid. As you can see, all the particles are actually arranged in fixed position. Okay, and it's a very regular arrangement. So it says that it's very closely packed together. For liquids, okay, strong forces of attraction between them. They are relatively close, but there are spaces between them. For gases, okay, we call these forces negligible because they are very weak. But they are not zero. It's just that it's so little that, we can consider it to be negligible. So these are how gas particles are being arranged. And that is why they do not have a fixed volume. They do not have a fixed shape because a lot of space between them. Okay, they are very far apart. Okay, they fill the container entirely. Okay, and then for the liquid, right, takes the shape of container, but the solid has got its own fixed shape and fixed volume. Okay, so compressibility, I think you should be familiar with this. All right, only gases can be compressed. So how do the particles move? For solids, they vibrate about fixed position. Liquids, okay, particles will slide over each other throughout the liquid. For gases, they move at very high speed. They move in different direction. Okay, so there's no fixed direction for them to move in. Now, this is the graph, which will tell you what happens when the change of state, okay, takes place. So in the video, you saw that we heated the solid, right, which is the ice. So when you heat solid, the temperature will rise. All right. Okay, for ice, usually when you take it out from the fridge, it's a negative temperature. Okay, your freezer is extremely cold. Go and check the setting. Okay, my own freezer, the setting is at -9. Okay, some of yours will be lower depending on what you need to keep inside the freezer. Of course, there are those industrial freezer, right? Then the temperature is extremely low. Okay, when I was younger, I used to do part-time in McDonald's. So they have a walk-in freezer. Okay, so the walk-in freezer is extremely, extremely cold. Okay, so we just open the freezer door. We will go in. We will carry out whatever food that we want to cook. Okay, and because the kitchen runs out of fries and the patties very soon, right? So somebody has to walk upstairs, go to the freezer, open the door, and bring down whatever we need to stock up. Okay, but it's extremely dangerous to go on your own because you might be locked outside. Okay, sorry, locked inside. So someone must stand outside to ensure that the door is not locked. Okay, otherwise nobody can hear you. So when we walk in, it's extremely, extremely cold. You will find that your goosebumps will all appear, right? And then the temperature setting, I think was minus, can't remember, I think it should be at least minus 20, 30, or even 40, minus 40, because you are storing a lot of food stuff inside. Every time you open the freezer door, you are allowing heat to go in. Okay, that one I have to confirm again. Okay, I suddenly recall that I worked there, and then that was my own experience. So you can also check on the industrial freezer. There should be different types with different temperature. Now, again, come back to this one. Let's say it is not ice I'm talking about, and it's just a normal solid at room temperature. Because if I want to apply to this graph, you see that the temperature, okay, at A is not 0, correct? So assuming this is the room temperature, okay, it's above 0. 0 should be here. So what happens when I start heating this solid? The temperature rises, okay, definitely will rise. You will do certain experiments in school, maybe not now, maybe in Sec 3 or Sec 4, but there will be many instances where you need to measure melting point, boiling point, etc. So this solid particles start to gain the heat, right? Converting it to kinetic energy. Then particles vibrate faster, but still in fixed position. Okay, temperature keep rising until a certain temperature where you start to see something happening to the solid. Okay, certain parts of it will start melting. So this is the melting point, and melting takes time. All right, because it depends on how big that solid is. Okay, and then depending on how much heat you are supplying. If you are supplying a lot of heat, of course, melting will take place faster. Okay, so in this case, look at what happens to the temperature. I have to continue supplying the heat, right? But how come I keep trying to heat that substance? The temperature did not rise. What happened to the heat energy? This is how you explain. Okay, and this is very, very important, always being tested. But students lose mark here because they didn't learn entirely how to explain this. Okay, so I think you are familiar with this one. Are you familiar?
Kind of.
Kind of. You know, temperature remain constant. You know the graph, but the explanation part, if you're not strong, if you're not clear, you lose marks there. Yeah. So temperature remains constant. Why? Because heat energy that is gained by the particles, right, is used to overcome attractive forces between particles. Remember, they are held in fixed position. In order for them to start moving around each other, the attractive forces need to be overcome. Okay, so when these happen, right, okay, some particles move out of fixed position, they start to slide over each other, resulting in irregular arrangement. So this point here, point C, is where melting is completed. So that means throughout CD here, I just have liquid state. So I continue to supply the heat, right? Particles will gain heat energy, temperature rises for this liquid. Kinetic energy causes the particles to slide over each other more rapidly. Okay? And when I continue heating, there will come a point where boiling starts. So during boiling, temperature stays the same again. Now, the way I have written it for you, you don't have to memorize too many different sentences, correct? As you can see here, it's the same thing, the explanation. Temperature remains constant. Heat energy gain is used to overcome attractive forces between particles. Some particles move further apart and start to move freely and rapidly in different directions. Must know how to explain. When you try out this, you will understand whether you have fully remembered what happened. Hey Yin, is that all right, Hey Yin? Can I can't see you. I can only see the head. Yeah. So right after, boiling is completed, you only have the substance in gaseous state. So this is the range E to F. Particles gain energy, okay, and then converted to kinetic energy, then the particles will move at higher speed. All right. So there is this part I think I want to check with you because I have the lesson with another group of Sec 1 on Thursday evening, right? Seems like, they didn't really understood certain parts. So let me ask you, for example, what is room temperature? Do you all know? Did you?
Is it like between 25 to 30 degrees? Somewhere around there.
Yes. Okay. In our syllabus, in science syllabus, in chemistry, okay, we take room temperature to be about 25 degrees Celsius. All right. We just fix room temperature pressure at 25. Why? It's easier for students. Okay, if I tell you, then you have to measure if I tell you to state the room temperature based on the current one, then every day you have to measure, correct or not? So we always use about 25. So at 25 degrees, imagine probably this is 25. Okay, as I start heating this solid, temperature rises, right? Okay, so let's say I don't use graph, I use a number line instead. So let's say I start off with 25 degrees Celsius. I start heating this substance. It will come to a temperature where it will start to melt, right? Okay, imagine this melting point. MP is melting point. Okay, so probably 47 degrees Celsius is the melting point. So what happens during melting? Okay, the solid starts to change to liquid state. So I can have solid here. Okay, and then after melting, I will have liquid, right? Agree? Yep. So after melting, if I continue to heat, the temperature continue to increase up to a point where you reach the boiling point. And this is probably maybe just 95 degrees Celsius. So after boiling, what happens? What state do we have? Gas. Okay. If I continue to heat this gas, assuming it is in an enclosed environment, of course, the temperature continue to rise. Okay, but if it's not enclosed, it's just going to escape into the surrounding. So this is what happens. You might think that this is easy, right? Later, when we do our open-ended question, you will know what I mean. Okay, so when I look at your responses, some of you didn't do your work. Okay. Let's see. I just checked. Hey Yin, you did it, right? But Hey Yin, I think you didn't do the open-ended question. Is that right?
I think the one question where I'll take my credit on it. Because they ask us to draw or something.
We go through together later. Now, I understand that some of you already starting to have the holiday mood. Your school have a lot of activities, right? VIA, you probably have your sports day, sports carnival, cross country. Many schools are having that. Are y'all doing that also?